Hi, we're Team 14 and this is a detailed walkthrough of our repository, process and code. We're a team of 8. The ninth member in our organization is our TA, Kashish. We would first like to show you our project Kanban board. This board is what we use to organize our tasks and plan our sprints. When we have an idea, it becomes a draft which goes on to the backlog section. Once the idea is formalized, we assign a priority, a size, and an estimate for how long the task would take to be completed. Then the backlog item moves to the ready stage. At this point, it is ready to be picked up. We either assign the tasks to our team or one or more members of the team volunteer and pick it up. At this point, once a team member or members pick it up, it goes to the in process stage. At this point, an issue gets created in our repository and also a branch with the same naming convention. Once our team is done working on that task, they raise a pull request for the same. This is when the item moves on to the in review stage. One or more members of our team review the pull request and either contemplate on it further or choose to accept or reject it. At this stage, the item moves on to completed or done part of our Kanban board, and the issue is closed, so is the pull request, and the branch is pruned. Okay, let us now look into our repository. This is our main branch. The .github folder consists of our issue templates. We have 3 for bug, custom, and feature. It also has the YAML files for our CI pipeline. And lastly, it has a template for our pull request. Next, Husky is our pre-commit hook that checks the quality of our code and commits before pushing it onto the branch. The admin folder contains all our architectural decision records. It also has the documentation and pictures regarding our CI/CD pipeline, which include our testing. The meetings folder contains our meeting notes for meetings like sprint planning, sprint reviews, retrospectives, etc. And lastly, the videos folder consists of our status video that we use to check in week 9. Moving on to Playwright. Playwright is what we use to do our end-to-end testing. The specs folder has our initial documentation that we had come up with for the design of the product. So it has a PDF that elaborates on the user personas that we had drafted, and it also has a soft pitch document. SRC is where our source code rests. We will talk about this in detail in a bit. Lastly, the tests folder contains the JavaScript for our end-to-end performance and unit testing. Let me now show you one of our issue templates. When you hit new issue, it gives you these 3 options. Assuming that I want to report a bug, I hit get started here, and then it gives me the convention for the issue title, and then it asks me to describe the bug, what steps do I need to take to reproduce the bug, what the expected behavior should be, any screenshots if I'd like to share them, the OS and browser versions I'm on, and any context if I'd like to provide. Okay. Moving on to pull requests. Let me show you a pull request. The title always starts with the type based on our semantic versioning. For example, feature, fix, chore, docs, etc. Each of our PRs is assigned to one or more of our team members, and our branch protection rules require that every PR is reviewed by 2 or more team members that have not contributed to the pull request before it can be merged onto main. Moving on to actions. This is where our codicy, linting, and tests are set up. Let me quickly show you the checks that ran on the last PR that was merged. You can see that code quality, unit, end-to-end, and performance testing, all these checks ran on the previous PR, and all of them had to be passed before it could be merged onto main.
Quickly go over the source code of our tool called Devings. We have the assets folder containing the logo for the dark and light modes of our app. We have the stylesheet.css file. Since we don't have any routing within the extension, we just have included all the different styles within one single file. Entry.html defines the skeleton of the app. It includes the main CSS, the main JS files, font awesome icons, and as can be seen in the extension, it always includes this header with the logo and a greeting and this toggle. So this has been defined. Finally, the JS folder, which has the code modularized into separate concerns. We follow the controller repository service architecture pattern, and we have an entry.js, which acts as the main component or the container for the entire app structure, similar to how app.js works in React. It basically links our UI in the HTML with the views logic that have been defined in the components. Components consist of the logic for manipulating the UI. We have models that define the different schemas for the objects. We have the repository, which takes care of the views and the service interactions by acting as an interface for the different CRUD operations. And finally, we have the services, which takes care of the database or the storage operations. Starting with the services, we have a client-side application, so we do not use any external storage. Initially, we were using the Chrome Storage Sync APIs, but we ran into a storage limit, and hence we decided to move to IndexedDB as documented in one of our ADRs. The shift was fairly simple though, because our code was modularized, and we simply had to replace this one file under services. For the models, we basically have two classes. First is the node, which represents the main node container that is linked to the different websites through the URLs. And one is for the node cell, which represents the different markdown or code cells within a node container. Nodesview.js is the main component. This fetches the node container for the current URL and renders the different node cells within it. If no such node exists, then it also creates a node and adds a new cell by default. We've also handled the case where if you try deleting all the different node cells, it will create a new node cell by default. There's logic in place to add new cells using the buttons at the bottom of each of these cells. These appear on hover, but the buttons for the last cell are always visible for an intuitive design. For the markdown cell, we have this toolbar um, showing all the different options for the user. Let's say you want to add some link, and you can preview it using this M button. You can even select the text and add some styling. Let's say I want to create a bullet, and this is how it works. So all of this logic resides in the markdown toolbar.js. Using prefixes, suffixes, we've also added keyboard shortcuts to increase the accessibility. And when it comes to the parsing, it is done using markdown rules.js, which consists of the different regular expressions. For the code cell, we have syntax highlighter.js. Currently, we are only supporting Python, and this file can, of course, be extended for other languages later. In the code cell, we can have different syntax. It indents correctly, and it also highlights the keywords. There is some discrepancy in the way the cursor moves, but we tried implementing this in the last sprint, so we weren't able to fix this one. Moving on to the tests, we have unit tests implemented using Jest for the node repository CRUD operations with the database, then for the UI CRUD operations, and for the parsing done with the help of Markdown. We weren't able to cover the test for the code editor. E2E and performance was implemented using Playwright because that's the best suited for Chrome extensions. It comes up with a Chromium headless server and tries to run all these operations within it. For the performance, we tried to cover this case where we load all the nodes within 1 second, and we try to handle large number of markdown and code cells within 5 seconds. And E2E takes care of the application holistically.
We have manually uploaded our extension to the Chrome Web Store and we're waiting on Google to review our submission. That is why our CD has not been deployed yet. However, our CI is very well set up. Once someone raises a pull request, our CI runs the following checks. It first performs linting, then it uses Codacy and Prettier to check overall code quality, and then we perform the unit tests we've written. At this stage, code coverage test happens as well. And then finally, end-to-end and performance tests are done. Once all these checks are done, the code is then merged. Now I'd like to talk about a couple of processes that our team followed. The first process was pair programming. At the beginning of the quarter, we divided our team of 8 into 4 pairs based on expertise, availability, and comfort. And these pairs worked with each other throughout the quarter and came up with some really interesting ideas and features. I think pair programming worked really well for us, as in our productivity was much higher than it would have been if we contributed individually. The second process that we followed was rotating meeting leads and note keepers. For every meeting, we had a new meeting lead and a note keeper. And we also asked every member of the team to submit a small write-up on what they would like to address in the meeting about 1 hour before the meeting. This acted as a checking function that everybody did prepare for the meeting. Not just that, rotating meeting leads also ensured that accountability and responsibility was shared among all team members and not just the team leads.